Hey everyone, Mr. Refrain here. Today we're going to start our new content with trigonometry. I'm going to do 3 lectures this week, and then next week I will not be doing any lectures because we're going to spend 2 weeks on this content, and next week is just going to be a review week. So next week I'll assign some review assignments to you, and there won't be anything new. So I won't be speaking to you guys like this for another week after this. But, you can always say hi to me in the discussion board and things like that, and I'll say hi back. Some of you guys have been commenting on my YouTube videos. I just want you to know that if you do comment on my YouTube videos on my teacher page, that I do read them every time, and I always respond. So, I don't know if you've been reading my responses, but I've been saying hi back. Yes, hi Kimmy. I don't know if you can hear my cat meowing. That's my cat Kimiko. She's my cute little kitty. She spends a lot of time with me, laying in this chair that I'm in. Yes, Kimmy. I know. I'm sure you guys have heard by now, but we're going to be doing distance learning for the rest of the school year. So I think that's for the best for all of our safety. So I'm crossing things off my list of things to talk to you guys about as I go through them. Kimmy wasn't on the list. Let's see. Oh, in terms of assignments being due, I went ahead and just to make things a little more consistent, I'm just gonna move all due dates to Sundays of every week. So every week things are due Sunday, and then it just helps keep things organized instead of having like a random due date for a test on Tuesday or something. So it should still provide enough time. It's a full week to get all of the work done. And this week there is no test, so that's nice, right? You don't have to worry about that. Before we get started on the lesson, I wanted to I'll just get started with the lesson, and I want to talk about some coronavirus stuff with you guys, but I think I'll save it for the next lecture, and that way each lecture has something a little bit interesting. This one had Kimiko. She's my little rock star. Aren't you, Kimmy? Kimiko. So you got to meet Kimiko through my my Blue Yeti. Yes, kitty. And so that's enough excitement for that. Now it's time for math. Okay, so this is 12.1 Trigonometry Basics. You know that from up here. And this whole week and next week is review from geometry. I think it should be pretty easy because you've learned all this stuff already. It'll be a little more advanced, but not much more advanced. You know how it is. Just like the step from Algebra 1 to Algebra 2. Hardly a change. Okay, so first let's talk about the Pythagorean theorem. There's a formula for this, right, that you guys probably already know, which is 8 squared plus b squared equals c squared. And when you use this formula, you have to have a right triangle, okay? So you can't use non-right triangles. Must be a right triangle. It's a right triangle because it has a right angle right here, signified by the box. So here's my right angle, which makes this a right triangle. And then the only thing that really matters for setting up this equation is that from the right angle, if you go across from it, right, this side right here is called the hypotenuse, which, that's a lot of spelling, so let's write hype. That's the hypotenuse right there, and that is always C, okay? So when you set up this equation, C is always the hypotenuse. These other sides are not. These are just legs. And it doesn't matter which one's A and which one's B, because you are squaring them and adding them together. So if I do 2 squared plus 3 squared, that's the same thing as, that's a square. That's the same thing as, well, that looks terrible. 2 squared plus 3 squared, I promise it says that. 2 squared plus 3 squared is the same thing as 3 squared plus 2 squared, right? And if you don't believe me, do the math. So it doesn't really matter which one's A and which one's B. All it matters is you don't screw up the C. Okay? So I'm just going to go over one of these problems because they're pretty easy and straightforward. I don't think you guys shouldn't struggle with this. So here's my right triangle. This is my right angle. So this is my hypotenuse. This is C. And I'll call this A, and I'll call this B. Again, it doesn't matter. This could be B, and this could be A. But you should label them each something. And so if I do A squared plus B squared equals C squared, then A is 4. So I have 4 squared. Plus B is 8. So we have 8 squared equals C squared. 4 squared is 16, plus 8 squared is 64, equals C squared. 16 plus 64 gives me 80. So 80 equals C squared. And then we take the square root of both sides, right? So I get C equals the square root of 80. And now, obviously, if I have the square root of 80, I can just type in square root. Hold on, square root. What is it? Oh, just saying square root. Okay. So yeah, you guys might know this, but in things like Desmos and some other programs, you can, instead of hitting the square root button, you can type commands that turn into the button. So if I type an SQRT, notice it turns into a square root sign right there. And I personally like doing that because I don't like moving between keyboard and mouse. So if I do square root of 80, here's my answer. It's 8.944 blah blah blah, all this crap, right? And typically on a test, we would tell you something like round to the nearest hundredth, and that's round to the nearest hundredth. But this question wants something a little more from us. It asks us to give our answer in simplest radical form. And so recall, you did this in geometry, and I think you did in this class, right? Simplifying radicals. So if I have this, the square root of 80, right, what does that break it down to? Breaks into, let's say, 4 and 20, which is, hey, that's actually today's date. And so this is square root of 4, and the square root of 20. We know square root of 4 is 2. And square root of 20 can be broken into the square root of 4 and the square root of 5. Square root of 4 is 2. You can't simplify the square root of 5. So what do I have? I now have a 2, and a square root of 5. 2 times 2 is 4. So my final answer is just C is equal to 4 times the square root of 5. And we're done. Okay. Oh, also, another announcement. In terms of course content, I had told you with great sadness that we wouldn't be doing the combinatorials and permutations, but after talking with the Algebra II teachers, I think it's back on the menu. So the thing that I said was, in my opinion, the hardest thing in Algebra II, it looks like we're going to be going over it again. So I'm very excited to teach you guys that. I hope you look forward to it too. I was very sad that we wouldn't be doing anything, that cruel. Yes, that's what I'm looking for. Cruel. Gotta make sure that you are having the proper Algebra 2 experience. Okay. And then also, in geometry, you learned about some specific kinds of right triangles, okay? And you learned about the 45-45-90 triangle and the 30-60-90 triangle. And they are named adequately because The 45, 45, 90 triangle has three angles. It has a 45-degree angle, a 45-degree angle, and a 90-degree angle. And you guessed it, good job. The 30, 60, 90 triangle is called the 30, 60, 90 triangle because it has a 30-degree angle, a 60-degree angle, and a 90-degree angle. Woo! So that's why they're called what they are. And I absolutely don't expect you to memorize these. I don't think I probably wouldn't have them memorized except for the fact that, I teach this class. So, it's a unique kind of suffering that I have to go through to have these things down. And what we know about a 45, 45, 90 triangle is that there is a ratio between these side lengths, and that ratio is x, and x root 2, okay? And x can be anything. So my legs are x, and x root 2 for the hypotenuse. And what that means is if you know one of these sides, you can quickly determine the other two sides. So for example, on this, if the leg here is like 5, well, if you know this is 5, this is x equals 5. Well, if x equals 5, then this is also 5, right? And if x is 5, then this is 5 root 2. And look at that. Now you know all of the different measurements of this triangle. So I don't know if that'll actually be on your special right triangles will be on your test. I assume Pythagorean theorem. I know Pythagorean theorem is on your test, but it's good to make sure you're familiar with that stuff. 30, 60, 90 triangle has the ratio of x, 2x, and gotta think about space, x root 3. Okay, so we identify these sides as such. Okay, this is the long one's the hypotenuse across the right angle, so this is my hypotenuse. And then we have a shorter leg and a longer leg. And the way that you identify these is by, and you can use your eyes, of course, and be like, duh, this one's shorter and this one's longer. But sometimes pictures aren't done well in math. So how can you tell for sure? Well, recall from geometry that the shorter leg is across from the smaller angle. So here's my 30 degrees smaller angle. Across from that 30-degree angle is our shorter leg. Okay? And then, let's use a different color. Not orange. Why don't they have like, where's purple on this, huh? I feel like we're missing other colors. Somebody better with colors will have to look at this and tell me, what's it missing? Because I really feel like there should be something else here. Anyway. And then here's my 60-degree angle. And 60 is much bigger than 30. So across from it is a much bigger side, known as the longer leg. Okay? So that's where those names come from. So the shorter leg is x. The longer leg is x root 3. And the hypotenuse is 2x, right? So if I have root 3 squared plus 1 squared equals 2 squared, right? This becomes 3 plus 1 equals 4. 4 equals 4. Yep, okay. Making sure I actually have these numbers right and I'm not giving the wrong stuff. Similarly, 1 root 2, this becomes 1 plus 1 or 2. This becomes 2. Good. So, all I was doing there was double checking my numbers with the Pythagorean theorem by making x equal to 1 in both of these. And that's good advice on your test, because these things, like, who really is going to remember in life that the ratio in a 30, 60, 90 triangle is x root 3, and 2x? Certainly not me, aside from the fact that I have to teach it to you. So it's good to help you remember. You can make x anything you want, right? Well, if x equals 1, then this is now 1. The short leg is 1. the long leg is now the square root of 3, and hypotenuse is now 2. So is root 3 squared plus 1 squared equal to 2 squared? Yeah, it turns out it is, right? 4 equals 4. So it's a good way for me to verify that these numbers work out, and being able to apply the Pythagorean theorem to these can help you remember this. In fact, if you use the Pythagorean theorem on the 45, 45, 90 triangle, you don't have to remember the rule at all. But I'll leave that as an exercise to the excellent student. Okay, so let's look at the number, crapola. I'm going to do number 3, and I'll do number 6. Yeah, because I don't want to, I want to make sure that you get one practice with the 30, 60, 90, one practice with the 45, 45, 90. So right away, I notice there's a 45-degree angle here, which means this angle must also be 45, right? Because all triangles their internal angles have to add up to 180. So if I have 45 and 90, subtract 45 and 90 from 80, and you get 45 for this third angle. So I have a 45, 45, 90 triangle, and you know that this is my right angle, which means this is my hypotenuse. So that means that these are my legs, which are equal to each other, right? Because the legs are both x, as you can see up here. So if this leg is 10, then x must be equal to 10. And y, which is the hypotenuse, is just x root 2. So if x is 10, this is 10 root 2. That came out pretty nice. Okay, so it's just applying this rule up here. There's no math involved. I did 0 math there. I didn't skip any math. There is no math. That's right, Kimmy. No math. Getting Kimmy some neck scratches. Okay. Number 6. So if this is a 30-degree angle, this is a 60-degree angle, which means right here, this is my hypotenuse. Across from 60 is my long leg, and across from 30 is my short leg, okay? So here's my hypotenuse, and here's what I strongly recommend. Get to the short leg, okay? Because once you have the short leg, if the short leg is x, well then the only things to do are multiply x by root 3 or x by 2 for the other sides, okay? What I really recommend you don't do is, here we're given the hypotenuse, which is 2x, right? So my 8, that's the same thing as 2x. We're doubling our x, which obviously means that x is 4. So my short leg, x is equal to 4. And what I really recommend that you don't try to do is go from the hypotenuse to the long leg, right? Because if you have the hypotenuse at 2x and the long leg is x root 3, it's hard to go from 2x to x root 3. At least it is for my brain. I find it much easier to go from 2x to x, and then once you have x, it's very easy to go from x to x root 3, right? Right, we have x equals 4. So what's the long leg going to be? Well, it's x root 3, which is just 4 root 3. So that's very easy. I'm assuming there's a y right there, because I don't want to scroll down, because remember the magic or epic pen this app is called that lets me write all over whatever was on my screen. Thank you to Mr. Schott for introducing that to me. Okay, so that's the deal with 30, 60, 90 triangles and 45, 45, 90 triangles. I won't go over any more of those because it's just straightforward math. It's pure memorization. There's no reasonable way for me to show you how to derive that stuff, okay? In fact, I can't even, we're about to do some trigonometric functions, and I can't even show you how to derive those because it involves trigonometry, or sorry, it involves calculus. And you don't know calculus. And in fact, I don't know the calculus to show it to you. I'd have to learn it anyway. So, here we are, son of a gun. Okay. So I'm just going to read this part off to you. A trigonometric function is a function whose rule is defined by a trigonometric ratio. A trigonometric ratio compares the lengths of two sides of a triangle. The Greek letter, what Greek letter do we got going on here, okay? We got this wonderful Greek letter called this. This is called theta. Okay, there's theta. So what is theta? Theta is nothing to be scared of. Don't be intimidated because it looks funny. It's just x. It's a variable, okay? But you guys know, you can use any letter as a variable, right? Sometimes in equations you have r, sometimes you have x, sometimes you have y or z. And when your teacher is feeling lazy, like me all the time, there's like a go-to variable, right? It's x. Every teacher uses x when they're feeling lazy and they don't want to be creative, I guess, with their letters. And theta is the go-to lazy symbol for variables that are angles of things, okay? So right here, here's my triangle. And there's A, B, and C for the sides, and theta here is used for the variable that represents this angle right here. So like this is if this was a 30, 60, 90 triangle, and I'm not saying it is, but if it was, then theta would be equal to 30, okay? Or 60, sorry. Let's pretend I said 60 the first time. This would be equal to 60 here, because it's across from the long side. I don't know why, to me, like at a glance, I really feel like 30-degree angles and 60-degree angles look like exactly the same. It seems ridiculous to me to say it out loud, but it's true. And I have to look at the side lengths right here to figure out which one's 30. Like I look at the short one, like, oh, that's across from 30. Here's the long one, it's across from 60. I don't know. 60, 30, they're like the same freaking number, Can't even tell the difference. Okay, so, and you might recall from geometry last year that we have a special kind of way to remember what we have these special trigonometric functions, sine, cosine, and tangent. And each of these are equal to some kind of ratio, some kind of fraction, okay? Sine is equal to the opposite over hypotenuse. Now, what is that? What am I talking about when I write this? Well, we're going to look at an angle, theta. So here's my angle of consideration, theta. Now, looking at the triangle from theta's perspective, there are three different sides. There's the hypotenuse, which is always the same, right? Here's my right angle, and here's the hypotenuse. So that is there's hype. And then here's my angle of consideration. And when I say angle of consideration, I just mean the angle we're looking at, right? If we're looking at sine of theta, this is my theta. This is not theta up here. This is not marked. It could be y, for example. Theta is what we're looking at. And across from theta is the opposite side, the side that is opposite of theta. So I call this my opposite. And then third, I have the side that is next to theta. Right, here's what's next to theta. And we have a word in geometry for what's next to theta. It's adjacent. So I have three sides: the adjacent side, the opposite side, and the hypotenuse. And it matters where theta is. Because if theta is up here, then if this is theta, okay, let's just do a little crappy pretend theta. If this is theta, well, across from theta, this is now the opposite, okay? It wouldn't be the adjacent, it would be the opposite. So if theta is flipped between the two positions, the opposite and adjacent sides are also flipped, okay? So if I want to figure out the sine of theta, I take the opposite side over the hypotenuse, which in this case, for our theta right here, what's the opposite? It's A over, and what's the hypotenuse? It's C. Okay, so sine of theta is equal to the side that is opposite of theta divided by the side that is the hypotenuse of the triangle. The side that is opposite of theta is A, And the side that is the hypotenuse of the triangle is C. So it's A divided by C. Cosine and tangent have similar rules. Cosine is equal to the adjacent over the hypotenuse. So if I look at this, what's the adjacent side? The adjacent side is B. So it's equal to B over, what's the hypotenuse? The hypotenuse is C. So it's B over C. Okay, so on your test, I'm telling you right now, there's a big question that's worth like 30% of your test grade, where you have to tell me sine, cosine, tangent, and these three that we're going to talk about in a second for a triangle. Okay, so be comfortable with this. Tangent of theta is equal to the opposite over the adjacent. So what's the opposite side? The opposite side is A. And what's the adjacent? The adjacent side is B. Okay? And there's a special mnemonic device that we use to remember, because this is like, what is this crap, right? This is really hard to remember. And so we have something special to remember this called so ka toa. Now at this point, I'm going to let you all know that you're going to go over this next year for pre-calculus. This is like technically not Algebra 2 content. We're now at the point where we're kind of done with the Algebra 2 content, and we're doing that part of a math class where we're prepping you for next year. So whether you are taking, if you're taking pre-calculus, you're going to have a whole section on trigonometric functions, and they're a lot worse than this too. Like, so much worse. And I really recommend that you get comfortable with these and memorize SOHCAHTOA and all these rules so that you aren't brutalized next year. And of course, if you're taking trigonometry analysis of function, you're going to be doing all this stuff that's trigonometric and you're taking trigonometry, right? So if you're taking either of those classes next year, you're going to be doing this stuff a lot. Unless you're taking probability and statistics, which is, in my opinion, the superior course to take. Unless, if you're in over trigonometry, at least. Over trigonometry, probability and statistics is superior. But pre-calc on to calculus is a good path. Okay. So what does SOHCAHTOA stand for? You want to break this into 3 parts. There's so, and that so, this S stands for sine. OH stands for opposite hypotenuse. Opposite hypotenuse. So this is SOH, so. And then we have CA, CAH, right? CA. And then we have TOA, TOA, oh, wow, I just deleted that too. Way to go, Dufresne. What was the adjacent again? B over C. Okay, so tangent is opposite over adjacent. What was I doing again? I was going to do it like this. Here's TOA, T-O-A. Here's T-O-A. Okay, so it's this SOHCAHTOA is to help you remember these rules. So, sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. TOA, tangent is equal to opposite over adjacent. So S equals over H, C equals A over H, and T equals O over A. Okay? Don't forget those rules. They are essential. And now we have something very special, which is 3 new trigonometric functions, right? We learned about sine, cosine, and tangent. And now we got cosecant, secant, and cotangent. You didn't know there were more than 3, huh? There's more than 3. There's 6. Wow, how great is that? Well, the hardest part about cosecant, secant, and cotangent is remembering the names and which one goes to which, because they actually aren't hard concepts at all, okay? Cosecant is just 1 over sine theta. So in other words, instead of being opposite over hypotenuse, it's hypotenuse over opposite. It's just sine flipped over, okay? So in this case up here, instead of being A over C, it's now C over A. So it's not hard to do. The math isn't hard, right? You're just flipping a fraction upside down. The hard part is remembering this word cosecant, and that cosecant belongs to sine, right? Remembering that cosecant and sine go together as a pair, that's the hardest part. Once you remember that cosecant and sine go together, it's easy to remember that they're reciprocals of each other, okay? And then secant is 1 over cosine, so instead of being A over H, it's now H over A. So before it was B over C, now it's C over B. So again, very easy. The math is not difficult. The hardest thing is learning that secant goes with cosine, okay? I wish I had like a fancy way to help you remember things, but you know, this has an S and a C, and this has an S and a C, so like, for me at least, I remember because I've done it for so long, but I never really found like a handy way to deal with it. Especially it's like, what's a secant? I don't even know. I've been doing this for a long time. I should look at the word secant. Be like, does that actually mean something? Who knows? Anyway, cotangent's easy because it's like tangent, cotangent. So not hard to remember. This cotangent is the reciprocal of tangent. So instead of being O over A, it's A over O. So instead of being A over B, it'd be side B over side A. Okay. Any questions on that? No? Okay, cool. Glad you guys find it so easy. I expect good scores from you guys. I haven't posted distributions of the tests. I don't know. I didn't know if anyone would care. If anyone wants to see the grade distributions from the tests, let me know and I'll post them. But if, you know, tell me in the discussion board or something. If no one cares, though, I won't do it. It's mostly just for me, right? For my entertainment. Whew, it's a lot of stuff, isn't it? Okay. So, we have... I'm going to do... Oh, okay, it's written down here. It's like, where's the number for this one? So I'm going to walk you guys through number 9, and then I'll leave 10 for you. And then, I don't know how much this I'll do. Let's see. So the first thing to do is this. You know, you guys are advanced. You can do intense stuff. So we only give you 2 sides. We need all 3 sides to do trigonometric ratios. So we're going to do the Pythagorean theorem first. So let's call this A, and call this B, and call this C. I want to figure out C. So I do A squared plus B squared equals C squared. A is 30, so this is 30 squared, plus B is 16, so this is 16 squared. I hope this is a Pythagorean triple, equals C squared. So I solved this by taking the square root on both sides, right? Which color am I using for this? This one? Square root. Square root. So that means C is equal to the square root of 30 squared plus 16 squared. I strongly recommend in these situations just using Desmos, okay? So I got square root of 30 squared plus 16 squared. And it's 34. I think it's a lot better just to type everything in Desmos like this. You can see Desmos Scientific up here. I think this is a lot better than doing the math step by step. So 34, great. Okay. So C is equal to 34 right here. Okay, so now I'm going to erase all this. Not all this. But I'm going to erase these letters, because we want to do something else with them. Actually, I don't want this in magenta, hot pink, whatever you want to call that. Let's make this... actually, is there black? Actually, look, is there a black color? There is black. Let's just do them black, okay? It's just 34. Ooh, it blends right in. You can hardly even tell I wrote that by hand. Looks like it's typed. Whew, okay, intense. And let's label our sides for a trigonometric function. So here's my angle of consideration, theta, which means if I go across from it, right, this is my opposite O, and next to it, this is my adjacent, A, and then across from the hypotenuse, or across from the right angle, is my hypotenuse, H. Okay, so anytime you're doing a question like this, I really recommend taking a second and labeling the sides O, A, and H to feel comfortable. It's very easy to get turned around when you're under stress in a test. In fact, I took a test like 2 weeks ago, and I got a 67 on it. I was very upset. And I got a 67 because the test was, like 8 pages long, and it came with 36 pages that I had to print out of reference tables and data to analyze. And I had 70 minutes to take the test. Well, as you might imagine, about a little over an hour is not a lot of time to go through 36 pages of data and even figure out what the heck that data is about, right? Like, I don't get to look at the data ahead of time. So it's like test starts, 36 pages, and it's not like the questions aren't even like, look at page 21 of the data. No, it just says, look in the data and figure out the answer to this question. So I'm scrambling through 36 pages of data in 70 minutes. And I was very upset with myself because I should have gotten like a mid B on that test. That was my knowledge level. But what happened on the test? Under stress, my professor likes to intentionally print off several tables that look like they're telling me all the same thing but have slight differences to see if we really know which table to look at. And in my stress, I misread the table labels 4 times. So 4 different times on the test. I did all the math right. I understood all the concepts, but the numbers I used for my tables were from the wrong data tables. So I got a D on a test because, under stress, it's easy to make small mistakes like this. So take it easy on your brain. You might think like, I'm too smart for that. I'm too smart to label these things. But labeling things and taking the time to do that are very helpful. And believe me, if I had, like 2 or 3 hours to take that test instead of 70 minutes, I would have labeled things a lot more thoroughly and not made those mistakes. So, anyway, just good advice. Okay, so what's sine of theta? And what I really recommend doing, like sine, cosine, tangent, cosecant, secant, and cotangent, don't mess with these guys. Okay, forget about them. Do the ones you're familiar with first, then just flip each one. So sine of theta, right? What's sine? Let's write our SOHCAHTOA. SOHCAHTOA. And so it's sine. Sine is opposite over hypotenuse. So it's over h. What's O? O is 16. What's the hypotenuse? Hypotenuse is 34. So it's just 16 over 34. Okay? And on a test, you might have to reduce that, or you might have to write it as a decimal or something. But for the demonstration we're doing now, it's sufficient. Cosine, what's cosine? Well, cosine is adjacent over hypotenuse. So adjacent is 30 over hypotenuse is 34. That's all there is to it, kids. Tangent is opposite over adjacent. Opposite is 16. Adjacent is 30. So it's 16 over 30. So what's cosecant? Remember, cosecant is just sine flipped. So instead of being 16 over 34, it's 34 over 16. That's it. Okay? Nothing scary. The scariest part is all these abbreviations and what in the world they mean. Secant is the reciprocal of cosine. So it's just 34 over 30. Cotangent is the reciprocal of tangent. So it's 30 over 16. Yay! That was a lot easier and faster than you thought, huh? Not too bad. Number 10 I'll leave for you guys to practice. The big hint is it's cosine of theta. Remember, cosine is adjacent over hypotenuse. So that means you can make a triangle like this, right? And the hypotenuse is 3. And if we create, here's my right angle, if we create a theta, the adjacent is 2. So you want a Pythagorean theorem to figure out what O is. Once you Pythagorean theorem to figure out what O is, which is, it's going to be O squared plus 2 squared equals 3 squared. Once you figure out what O is, then it's the same problem as this one, okay? So it has an extra step, and I did all the hard parts, all the thinking for you. You just have to solve for O, right? In fact, it's hard to stop myself right now. O is the square root of 5. Oh, see, I couldn't even contain myself. Oh, okay. So it's the square root of 5. Okay. Now, so I'll leave the rest to you guys. I had to stop now, otherwise, I'll end up doing the whole problem, and I gotta leave something for you guys to practice. If I don't leave anything for you guys to practice, that's not good of me. I have to restrain myself. Okay. And what's this last section about? Okay, so let's talk about these. These aren't bad. Aside from the fact that, who's going to remember them? So I taught you about some ratios here. For a 45, 45, 90 triangle, our sides are x, x, and x root 2. And for a 30, 60, 90 triangle, we have x, 2x, and x root 3, okay? And what we're going to do here is I think we'll see how many I do, because I don't want to take away everything from you guys to get practice, but I don't want to do too little so you're like, what in the world was Dufresne even doing there? Okay, so sine of 45. Remember sine. Let's write SOHCAHTOA again. Okay, always write SOHCAHTOA. When I was in high school, I wrote it every single time. And spell it right, okay? Some of the geometry kids that I teach, they spell SOHCAHTOA wrong. And, well, it doesn't go well for them. Let's just leave it at that, shall we? So sine is what? It's opposite over hypotenuse. O over H. So if I look at 45 here, let's label these. For 45 degrees, okay, this is my angle of consideration. So you can make this one the angle of consideration. That's the nice thing about the 45, 45, 90 triangle. It doesn't matter, right? Because adjacent and opposite are both x. So it doesn't matter. I can make this the angle of consideration and get the same thing. So this is O, this is A, and this is H. So if I write this out, what is sine of 45? Well, sine of 45 is equal to O, which is x, over H, which is x root 2. Boom. Well, now what? What's x over x? That cancels, right? So I just have 1 over the square root of 2. And then you have to remember we have a special rule, right? We can't have radicals in the denominator. So I multiply this by the square root over the square root of 2, and I get root 2 over 2. Your test is going to have questions like this where you have to give me these values and have them memorized. So, or derive them from this kind of triangle, okay? So, like I said, a little harder than geometry last year, but not much, okay? Cosine of 45, well, that's adjacent over hypotenuse, right? What's the adjacent? The adjacent is x. So it's the same thing. It's x over, what's the hypotenuse? X root 2. The x's cancel. Same thing again. I'm going to get root 2 over 2. What's tangent? Tangent is TOA, right? TOA, opposite over adjacent. Opposite over adjacent. And what's O and A? O and A are both x. So it's x over x, or 1. Simple? Simple? Okay. Let's do the same thing with the 30, 60, 90 triangle. Then I'll leave these last 3 for you guys. Okay. So sine of 30. Here's my... So you guys, when you do the 60 degrees, you'll want to mark this as your angle of consideration right here. And this will be O down here. And this will be A. I'm going to do the 30 degrees. So this is my O. This is my A. This is my H. Okay. So sine of 30, sine is so it's opposite over hypotenuse. The O is x over the H, which is 2x. And again, what happens here? My x's cancel. So what's my answer? It's 1/2. Not bad. Cosine of 30 is adjacent over hypotenuse. So what's the adjacent? Adjacent is x root 3 over, what's the hypotenuse? 2x. Let's cancel out these x's. And my final answer is root 3 over 2. Not too bad. Tangent, TOA, opposite over adjacent. I got O over A. So what's O? O is x. Over A is x root 3. Right? The x's cancel. That looks more purple than before. No, it looks the same. I'm just wigging out. So I have 1 over root 3. And again, no radicals in the denominator, so multiply by root 3 over root 3. My final answer is root 3 over 3. Okay, not too bad. So that's all I got for you guys on 12.1. That was pretty long though. But you know, long lectures this week, no lectures next week. It balances out if you do the math. Trust me, I did it. All right. Have a good one, guys.